In this problem, you have a 100 kg man is skiing across level ground at a speed of 8 meters per second. When he comes to the small slope 1.8 meter higher than the ground level shown in the following figure, if the skier goes up the hill, what is his speed when he reaches the top plateau? So what's his speed here? Assume the friction between the snow and ski is negligible. What is the speed when he reaches the upper level if there's an 18 Newton frictional force acting on the skis? Alright, so part A, when there's no friction. Okay, for part A, no friction. And when friction is not present, so energy at this location, there's only conservative forces acting on it. Energy is conserved. Okay, so kinetic energy initial plus potential energy initial UGI UG final. And again, we'll take this level as the reference level for the potential energy. So this is initial potential energy 0, mg y initial, and y initial is 0. So 1/2 mv initial square to the 1/2 mv final square plus mg y final. The mass cancels. That means every skier would, assuming no friction, will be going at the same speed at the top. Alright, so v initial square, you multiply this equation by 2, this to cancel, that to cancel, and that gives you 2 gyf v final square plus 2g v final square is v initial square minus 2gy final. Alright, so let's put in the numbers. It's 8 square minus 2 times 9.8 times 1.8. Okay, so V final works out to be 5.36 meters per second. Alright, part B, now we have to put in friction. Alright, let's add a page. Okay, part B now. They give you the friction force is 80 newtons and this distance is 8 meters. Okay, so when he's going up the slope, there's the friction force and there's the displacement. Okay, so now when non-conservative forces are present, work done by non-conservative force is equal to change in mechanical energy. So final mechanical energy minus initial mechanical energy. And the friction force does this much work, where F is the friction force and D is the distance covered, which is 8 meters. And so that's equal to 1/2 mv final square plus mgy final minus 1/2 mv initial square plus mgy initial. So there's the initial location, there's the final location, and so on. And y initial is 0, so this term is 0. So minus 80 newtons divided by, well, negative of 80 newtons times 8 meters is equal to one half mv final square plus mgy final minus one half mv initial square. Alright, so let's put in the numbers. 8 so 64 minus 640 joules is equal to half the mass of the skier is 100 kgs. And this is equal to mgy final. Y final is 1.8 meters. Okay. 100 kg times 9.8 meters per second squared, 1.8 meters minus 1/2 100 kgs times initial velocity was 8 meters per second. Alright, so without friction he was going at 5.36 meters per second, and with friction present at the top of the hill he should be going slower than that, and that's what we're hoping for there. Okay, so let's add another page. Okay, so what we have is minus 640 joules should equal 50 times V final square (1,000 plus 1,764 minus, and what is that term? V square 50 times 60 minus 3,200. Alright, so all this works out to, so 50 V final square is equal to 3,200 minus 1,764 minus 640 . Okay, 796, and so V final is square root of 796 divided by 50. .99 meters per second. And as promised, this speed is lower than when there was no friction present. Okay. Alright, this solves this problem.